All right, and learning target 5, 6, and 7, we're just using some more things we can do with radian measures. So if you think back to Unit 1, and like learning target 2, maybe, it said, given a certain number of rotations, say how many degrees is represented by that, right? It said, like, what angle measure is represented by 3.5 rotations counterclockwise. And you multiplied 3.5 times 360 to figure out how many degrees, right? Well, learning target 5 is essentially the same thing. We're just talking about radian. So we're going to talk about angular displacement, and that's a fancy word or fancy phrase. Angular displacement is just asking you, given a certain number of revolutions around a circle or circular object, how many radians is that? That's all it's asking. So if it says 2.3 revolutions, I want to know how many radians that is. Well, one revolution is how many radians? 2 pi. So instead of multiplying by 360, we're going to be multiplying by 2 pi. Okay? So this is all learning target 5 is. Determine each angular displacement in radians and round to the nearest tenth. So the first one says 5.8 revolutions. I want to know how many radians that is. So we multiply by 2 pi radians. As it's around the nearest tenth, so you just type that into your calculator. Typing things on my calculator takes a little bit of time on this screen, though, so I went ahead and did it and got 36.4 radians. 5.8. Questions about that? So the same thing for the second one, 710 revolutions times 2 pi radians. And that's approximately 4,461.1 radians. Questions about how to do learning target 5? Because that's it. I do not recall. No. Question. All right. Learning target number 6. We're finding the angular velocity. All right, now angular velocity is just saying how many radians something is moving in a certain amount of time. So if you think about like a point on the outside of a tire, right, your car, your tire is rotating, right? So we want to know how many radians it's moving in per minute, or radians per hour, or whatever. That's what angular velocity is, okay? It's radians per some amount of time. So you have this formula for angular velocity, which will be provided for you on the quiz. I just won't be telling you what anything stands for. Angular velocity is represented by a lowercase omega. That's what that W is. It's amount of radians an object is traveling in a certain amount of time. Whichever. It has to be circular motion, obviously. Now, time is in the unit of time. Days, hours, minutes, seconds, milliseconds, whatever you want to use. Theta up here, though, is not just radians. It has to be the angular displacement. So it has to be the number of radians given for a certain number of revolutions. Okay? So that's the angular displacement we talked about in learning target 5. So it says determine each angular velocity and round to the nearest tenth. So the first one says we have 3.2 revolutions in 7 seconds. I need to have the angular displacement divided by time. And right now I don't have the angular displacement. I have the number of revolutions, right? Right, so we need to do 3.2 times 2 pi first. That's the angular displacement. We want to change it from revolutions to radians. And then once I have that, I need to divide by 7 seconds. Make sure you do the numerator first before you divide by 7. So you should get, again, I did my calculator earlier, approximately 2.9 radians per second. The units will be important in this learning target in the next one. This one was in seconds, so that's why I have second. The next one's in minutes, so I'm going to have minutes. Any questions about the first example? So a point or an object is traveling around the circular motion at 2.9 radians per second. All right, so the second one, same thing. We need to change 700 revolutions into radians first. So we need to find that angular displacement. Once I have that, I divide by 15 minutes. And that is approximately 293.2 radians per minute. I wouldn't, because R can stand for radius. Any questions about these two examples or learning target 6? So finding how many radians an object is moving in a certain amount of time.
I'll check for you.
Thanks. Any questions, learning target 6? Going once, going twice? All right, learning target 7 then.
3. That's correct.
Find the linear velocity. Now, linear velocity is giving you an actual distance in a certain amount of time. So we're still going in a circular motion, but this time I want to know like how far that object has traveled in a certain amount of time. Okay? So we're going to be given the answer. It'll be like meters per second or feet per minute. All right? You're saying how far that object has traveled or that point on the tire has traveled. Okay? So we have this formula for linear velocity. V equals R, which is the radius of the circle, right? Because we need to know how large that circle is. It makes a difference about how far an object has gone, okay? So R is the radius. Then you have theta over t, which should look really familiar because that was the formula for angular velocity in the last question, in the last learning target. So theta is still a radian measure, and t is still time, so some units of radians per amount of time. So because we already know angular velocity is lowercase omega, you could also write that formula this way. V equals R times omega.
Wow. That's easier. That's the same thing.
So here's the thing. On most of the questions today, they're going to give you omega, and so you use the second one. If there was like a more challenging question or like a critical thinking question in the book where they didn't give you omega, you would have to use the first version, and then you would just figure out how many, probably they give you revolutions, you'd figure out how many radians, and then you to go from there. Okay? So for these two, to find linear velocity, we have omega is 36 radians per second, and the radius of the circle is 12 inches. So we have 12 inches, 36 radians per second, and 12 times 36 is 432. And this will be in inches per second. As linear velocity is giving you an actual distance in the amount of time. Questions about where I got 432? So on the second one, we have 7 meters times 5 pi radians per minute. And you get 109.96, so 110 meters per minute. Questions about that?
Is that it?